Hi everyone, and welcome back to another week working with different geometric figures. And this week we can see that we're not going to be working with triangles any longer, but we're going to be moving into four-sided figures. Now, four-sided figures can be squares and rectangles, but they can also be other shapes like those that we're going to get into this week. The first shape that we're going to start working with is the parallelogram, and that's what I've drawn on the screen here for us. And there's a lot of symbols right here on our screen. So what I'm going to do really quick is I'm going to hide the rest of the stuff down below just for the time being, and I'm going to go over to full screen. And for right now, as I'm taking a look here, I can see that I have a parallelogram, and there's some crazy arrow things going on here, and there's letters at each of the corners or the vertices. So let's talk about a few things here. So this parallelogram has a name. It's parallelogram A, B, C, D. It gets its name from the letters that make up the four vertices. A parallelogram has four angles. We see them right here. And these golden arrows that are on here mean something. And that has to deal with our properties that you guys saw down here before. So the first property that we're going to focus on is that opposite sides in a parallelogram are congruent and parallel. So what that means, if lines are parallel, they will never ever touch, okay? If we think for a moment about the lines that run down the middle of Main Street in Madison, those two yellow lines are parallel. They never ever touch. So parallel lines will never intersect at any point. So if we take a look here, line AD over here is parallel to line BC. Those lines will never touch. And we can mathematically show that by using the parallel arrow that you see here. So wherever I see one parallel arrow, any line that has the same parallel arrow drawn on it is going in the exact same direction. Now over here, we have line AB and line CD. We see that there are two parallel arrows on this particular line segment, for these two line segments, I should say. So here, there's two arrows. That means that that is parallel to any other line or line segment with two arrows on it. So AB is parallel to CD. Notice how they're directly across from each other. That's what we mean by opposite sides in the parallelogram. So again, AD is opposite BC, they're parallel. Or AD is opposite BC, I should say, and AB is opposite CD, and they're parallel. They're also going to be congruent. So if, for example, I said segment AB was 12, segment CD would also be 12. And if BC was 7, then AD would be 7. Now, one of the symbols we see here is this thing that looks like either quotation marks or 11s. Well, these are actually two parallel lines here. They're supposed to be perfectly parallel up and down, but drawing on the computer is a little hard. So what we do is we name our segments. So if we're writing, for example, segment AB is parallel to segment CD, I can click right here and write AB, and then is parallel to CD. And I'm just going to move that right there so I can see that segment AB is parallel to segment CD. And we use this to avoid writing out in very long form. Math teachers and mathematicians all use the parallel symbol like this. Over here, we can do similar work when we say segment BC is parallel to segment AD. And we'll put that right around the parallel symbol. So segment AB is parallel to CD. Segment BC is parallel to AD. And again, I would draw the line segment symbol up on top just to keep this all mathematically sound. So segment, 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 and segment. Okay, cool. The next thing we're going to take a look at is that opposite angles directly across from each other, but not on a touching line, are equal. So let's go and take a look at angle D, for example. Okay, and I put a blue arc inside angle D. So opposite angles, those are directly across from angle D, and they can't be on a touching line. So what that means is it's going to go across from angle D. So that's going to be angle B here. Angle B is not on a line that touches D. C, angle C over here, is on this line right here that leads to point or angle D. And A is on this line right here that again goes to angle D. So those are not opposite angles. Opposite means directly across the shape. Okay? Now these angles are going to be equal to one another. Now let's say that angle D was 60 degrees. Well, because opposite angles in a parallelogram are always equal, then angle B is also going to be 60 degrees. Wonderful thing, these parallelograms. The final property that we need to remember is that neighboring angles, and those are the angles that share a connecting line now. So remember how we ruled out C and A before? Well, now neighboring angles share a line together. They're going to add up to 180 degrees. So we can actually figure out what angle C is going to be right now. And I'm going to switch over to this pen right here. So if I want to figure out what angle C is, well, it's neighboring angle B. So if they together add up to 180, I could do 180 minus 60 degrees, and I'm going to find that this is 120. So angle C is 120. Now, could I repeat that same math for angle A and subtract from either angle B or D? Sure, but I can also remember that angle C is opposite angle A. So if angle C is 120 degrees, angle A is also 120 degrees. So those are the properties of our parallelograms. Please feel free to rewatch any section of that video so far. And we're going to go on and take a look at this parallelogram right here. What I've drawn here is a parallelogram. I didn't name the vertices at all, but I did name the angles inside. And we have angle A, B, and C. Now you can choose to do any of these angles any way you want, but I'm going to stop myself and say which one of these angles is going to be the easiest to solve for first. There's one angle in here that I don't need to do any math for whatsoever. I just have to remember one of these properties. And I'm going to use this property right here. Opposite angles are equal. So if I jump back to this parallelogram, I see my 50-degree angle is my acute angle here. Directly across from that is angle B. So that means angle B is 50 degrees. Now I have to do some math to figure out either angle A or angle C. And angle A is next to this 50-degree angle over here, or it's also next to angle B, which we just figured out was 50 degrees. So it doesn't really matter, okay? And sometimes what you'll see me do is draw a line down the middle of my figures so that I remember these are the angles that I'm going to use for my operation. Or sometimes I'll draw a line down this way and I'll say these two angles are what I'm going to end up using. I'm going to try to get rid of this line now. There we go. All right, so we're going to do 180 minus 50. And the reason for that is because neighboring angles add up to 180 degrees. So if I jump back over here and I do 180 minus 50, I'm going to learn that angle A is 130 degrees. Now, for angle C, do I have to do any math? I could steal this math over here, or I could again realize that angle C is directly across from angle A. And if angle A is 130 degrees, angle C is also 130 degrees. And if we look at neighboring angles, these add up to 180. And if I check these neighboring angles, that also adds up to 180. So the figure works out perfectly. Now here we have a different parallelogram, and I've inserted this line over here in the middle of the obtuse angle. And I give us that the acute angle is 58 degrees, and this entire angle up here, measures 122 degrees. So that entire angle is 122 degrees. Over here I have angle A in this corner as the acute angle. I've drawn in a 75 degree angle over here, and then I have angle B, which is also missing. So now I have to do a little bit of thinking here and ask myself, can I possibly figure out one of these angles, either angle A or angle B? Well, I can figure out angle A right away, right? Because it's an opposite angle. It's directly across from the 58. It's the acute angle. So the acute angles have the same measurement, 58 and 58. So I'm going to go ahead and fill that in. Now to find angle B, there are two strategies that you could use, and I'm going to model both of them here for you, and then when you go to do your own independent work, you can decide which one you like better. Now I know that this whole angle is 122, and it has to be congruent to this whole angle over here. And I drew that arc really big because I know that part of that angle is 75 degrees. So what is the other part? Well, I can do some subtraction. And I could say, all right, I'm going to do 122 minus 75. And I'm going to have 47 degrees for B. So this part right here is 47 degrees. And I can check that by doing 58 plus 47 plus 75, and my answer should be 180. What I can also do is realize these are neighboring angles right here, right? So if I'm missing one part of this, I could add 58 and 75 together and then subtract from 180, since neighboring angles altogether have to add up to 180 degrees. So if I do 75 plus 58, let's see, that's 13, and I carry, and I have 133, and then I have 180 minus 133. I hope my answer is 47. And it looks like my answers agree. So two different strategies for solving for the same angle, and I get the exact same answer. Today, what you'll be doing are some independent practice problems, again on a Google form. If you have any questions, as always, please reach out to us.